All right, everyone, this is section 1.1, part B. In your notes, I have this warm-up to start. If you guys would like to do that quick, pause the video. I'm going to start down here. Okay, 1.1 part B is basically the same thing as part A. We're just adding a few more vocabulary words in here. Okay, so we're still working with parent functions and transformations. Our goals and essential questions, still the same thing. All right. First term is vertical stretch. Vertical stretch. I'm going to give you guys the definition, and we'll go through some examples here in a little bit. But a vertical stretch is when we have a number being multiplied by our function. Okay? And that number, A, so our number is A. I just threw an A as a variable. It's a number. Think of A as a variable, or as a number. But A is going to be bigger than 1 when we're dealing with a vertical stretch. Okay, a vertical shrink is the same thing. Well, very close to the same thing. 8 times the function of x, so it's still a number times our function. But instead of A being bigger than 1, A is going to be less than 1, but it can't be a negative number. So it has to be bigger. Bigger than 0. Okay? So A is between 0 and 1, and it's being multiplied by our function. Another term here, another term that I want you to add is reflection. Okay? When it comes to reflection, there's 2 types of reflections. You can have reflection over the x-axis when we're dealing with functions. We can have our x-axis. So reflection over the x-axis. What does that look like? That's going to be a negative function. So it's going to make a negative f of x. That would be a reflection over the x-axis. And reflection over the y-axis looks like this. It's f, but instead of being negative f of x, it's f of negative x. So a little discrepancy there, a little different. But we're still talking about reflection and a vertical stretch and vertical shrink. Okay, moving on. Moving on to some examples. So we're doing almost the same thing as the first part. We are graphing a function and its parent function, and then we're going to describe the transformation. Okay? So here, I like to start with our function. I like to graphing it to start. Okay, so let's start with f of x. Okay? Well, remember, we have to have negative numbers and positive numbers. So I do 4 points, -2, -1, 0, 1, and 2. What's the absolute value? We have a 2 being multiplied by our function, right? 2 times the absolute value of x. So when we plug in -2, what's the absolute value of -2? Well, the absolute value of -2 is 2, and 2 times 2 is 4. So at -2, we're going to be at 4. When we're at -1, the absolute value of -1 is 1. And 1 times 2 is 2. So at -1, we're at 2. Okay. 0, the absolute value of 0 is 0. And 2 times 0 is 0. So at 0, we're at 0. And then when we just multiply 1 and 2, it's just the absolute value of 1 is 1. The absolute value of 2 is 2. So 2 times 1 is 2. 2 times 2 is 4. So we're going to be at 2 and then 4. Okay, so here is our function. Now, look back to 1.1a. What is its parent function? Its parent function is here in red. It is f of x is equal to the absolute value of x. Now remember, that starts at the origin and goes up 1 over 1 on each point. Hold on at each point. Okay, so, sorry, we got a parenthesis. Looking at our parent function and our function, we have to think, okay, what's the transformation? We have to describe the transformation. Well, it looks like it's being skinnier. Looks like it's getting skinnier. But remember, when we think of vertical stretch, I'm going to go blue, sorry, so it's easier to see. When we talk vertical stretch, we had f of x being multiplied by a number, and a was bigger than 1. Well, is this the case here, up here? Yeah, it is. It's being multiplied by 2. So this has a vertical stretch of 2. Vertical stretch of 2. That is our transformation. Okay. Excuse me. Man, something is in my chest. Okay. So yeah, that's a vertical stretch of 2. Moving on. Next function. So we want to graph our parent function and this function, and then describe the transformation. Well, I'm going to do this one a little different. Let's start with our parent function. What is our parent function? Remember, we have this x squared. Remember our parent function of our x squared, our fx equals x squared. Okay, and it made a U shape. Made a U shape, something like this. Okay, there's our parent function. And then this one, fx is 1/2 of x squared. I'm going to find some points. Well, we have -2, -1, 0, 1, and 2. Well, let's start with 0. 0 squared is 0 times 1/2 is 0. Okay. How about -2? What's -2 times -2? It's a +4, right? And a +4 times 1/2 is 2. So this is going to be 2. -1, let's plug -1 in. We have -1 times -1, which is just a +1. And a +1 times 1/2 is 1/2. Okay? What do we know about 1 and 2 then? They're going to be the same things, right? So we have another 1/2 and then we have 2. So let's plot this. At -2, we're at 1, 2, right here. At -1, we're at 1/2. At 0, we're at 0, 1/2, and then 2. Okay? I'm not really seeing a big difference here. Let's try 3. Let's plug in 3. What would 3 be? Well, 3 squared is 9, and 1/2 of 9 is 4.5. Right? So at 3, we're at 1, 2, 3, 4.5. Okay. Okay, well, we know that at -3 it's going to be the same thing, right? It's going to be right there. So this function is a little bit wider. Okay? Well, what do we call that? What do we call that? Well, we have a number out front, like 1/2. We call that a vertical shrink. Okay? Which I know looks maybe a little opposite to you because this graph is being wider, but it is a vertical shrink. Think when it's wider, it's shrinking. I know that might be backwards or opposite to you. And if it's getting skinnier, it's actually stretching it up. Okay. Think of shrinking as we're pushing down on the object. That's why it's getting wider. It's shrinking. And when we're stretching it, we're pulling it up. We're pulling it apart. And that's why it's getting skinnier. Okay? So it's the vertical shrink. Why? Well, when we have a number times our function, and that number is between 0 and 1, which 1/2 is, it's a vertical shrink. Okay, vertical shrink of 1/2. There's our answer. All right? This next one, I want you guys to try it. Okay? So pause the video and then come back when you're done. I'm going to work on this one. This next one, I'm not going to graph it. I'm not going to graph it. I'm going to tell you the parent function, and then I'm going to tell you how it transforms. So our parent function is f of x equals x, the absolute value of x. Okay. Now, when we talk about this transformation, we have to talk about, there's 3 transformations happening. There's 3. Well, which ones? We have x plus 5, we have minus 3, but we also have this negative out front. Okay, and I'm going to talk about all 3 of these. This x, well, when it's subtracted by 3 at the end, when it's outside of our function, so when it's outside the absolute value, when it's a minus 3, it's going down 3 units. Okay? When we have x plus 5 in our absolute value, remember, absolute values, they work as opposites. It's opposite. So if it's plus 5, we're not going to the right 5, we're going left 5 units. Okay? And when it's a negative, how does that work? Do me a favor, pause this video. Type this into a graphing calculator. Go on to Desmos. Type this function in. What do you notice? Okay? When you finish, you come up with a hypothesis, let me know. Okay? Or don't let me know. Unpause the video and come back to this video. Okay? Alright. What does that negative do? It flips over the x-axis. Flips over that x-axis. So there's our transformations. There's 3 transformations. That negative out front might be the hardest one to spot right away. Okay? All right. Moving on. Again, I'm not going to graph this one. You guys, I'm going to leave that up to you. I'm going to just talk about the transformations. Okay? First off, parent function f of x is equal to x squared, right? Our normal quadratic function. Now let's talk about our transformations. We have, again, 3 in this one. 3 of them. First one, hardest one to spot. Negative. Second one, 0.25 is being multiplied by. And the last one is plus 4. Start with that negative. And negative, what does it do? Well, it's out front. It's out front of our function. When we multiply our function by a negative, it flips over the x-axis. Axis. Okay, when we multiply by a number that's less than 1 but bigger than 0, it gets wider, right? So it looks like we're pushing down on that parent function. It looks like we're pushing down on it, and it's squishing it. We call that a vertical shrink. Of 0.25. Okay? And our last one, plus 4, does that move it left or right or up or down? I can't remember. Which one is it? Left or right or up or down? Well, if you don't know, graph it. Graph that. But I know that if it's outside my function, it's being added at the end, plus 4, that's going up 4 units. Yeah? All right. Lastly, domain and range. Identify the function family and describe the domain and range. Use a graphing calculator to help verify your answer. Okay. Well, in this first one, we have f of x is equal to x minus 3 plus 2. Our domain and our range. Okay. Our domain is our x-axis, okay, our y. Okay, I like to think of, imagine a king standing on a balcony in front of his followers and saying, "This is my domain," with his arms out wide. This is my domain. His arms are going left and right. Okay, that's domain, left and right. I'll explain this in a second. Our range is that of the opposite. I like to think of a vertical range. Basketball player, they like to jump. They have vertical range. Okay, high. They're jump up or down. So instead of left or right, it's up and down. Okay. So let's go to Desmos. Let's go to Desmos. Okay. Yep, that's what I want. Let's type in this absolute value. F of x is equal to, what was it? X minus 3, absolute value of x minus 3 plus 2. Okay. Now, when we talk domain, let's talk domain first. Our domain here. What domain means is for each point, so at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity, and negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. So from negative infinity to positive infinity. Okay? At what points, if I say 0, is there a point at 0? Well, yeah, it's at 0, 5. Okay? What about like 6, for example? 6 over here. Is there a point, if I plugged 6 in, will I get a value? Yeah, for sure. What if I said negative 5? Well, at negative 5, let's zoom out here. Oh, things kind of got messed up. That's fine. And negative 5, yeah, there's a point. It's right there. Well, what if I keep zooming out? Let's just keep zooming out. Is there ever an end to a point? If I had negative 4,000, look at that. If I had negative 4,000, there's a point. If I had point 3,000, there's a point right here. So is there a point to which there will not be a result for our domain? No, there's not. So our domain is negative infinity to positive infinity. Okay? Our range is the same thing, but think up or down. Okay, so let's zoom back in here. Back to our beginning. Our range is for every y, so at 0, if I go this way, is there a result? And there isn't. There's no result at 0. Okay? Our results for something higher than this is right here. Okay? And that's at y is equal to 2. Y is equal to 2. So is there any results down here less than 2? And there's not. Okay? Our results start at 2 and they go bigger than 2. Now, is 2 included? Yes. So we say y is greater than or equal to 2. Okay? You can go back to those notes, finish those last 3 or 2 or whatever it may be. Yeah, 2 of them on your own. Okay?